Hello everyone, welcome back to I think it's day 7 of Avalon Game Project. Today we're gonna try some TDD. So yesterday we implemented a very simple game setup state. We added some logic, added some skeleton services. So as I mentioned, according to the top-down principle and the inversion control, we want to implement the very core logic first, then leave the rest of the dependencies to the external environment as long as they meet our standards. So basically, implement our interface. So I think today I'll try to implement one more state and some of the player service. Let's see if we can do that. So as I mentioned yesterday, we definitely want to do some TDD, which is test-driven design. So before we start, again, let me talk a little bit. I think many of the software developers, especially new, fresh out of school, new to the industry, they do not care too much about tests. Unit tests especially. Unit tests, integration tests, end-to-end tests. I don't think they care about those that much. Actually, at one of my previous work, I think we literally fired someone for not willing to write tests. So I do not think it's worth. Okay, so let me rephrase. The importance of tests cannot be stressed enough. They are important, they are vital. We can't live without them. Why? First of all, you do not know if your code works, especially when you are writing hundreds of lines, hundreds of modules every day. It's really hard to know if things work, especially it's even harder when multiple people are working on the same code base. So we want a piece of code to first prove our code works, and the second, it can be easily re-executed the next time we change anything. A good set of tests also should work as a documentation, as what is the expected behavior of this particular module. So in the earlier stage of my career, I definitely have a habit of writing code first, then writing tests, claiming that this is better for me to stay in the flow, to finish the work first, then fix smaller issues. But actually, that's not the case. Yes, sometimes we do need to focus, but I think many people use that as an excuse of not willing to do the hard work. And I think I read a couple of articles saying or claiming that staying in the flow only gives you the illusion of you being more efficient. There's no proof that when people are in the flow, they are actually more efficient. And most importantly, when we are out of the flow, it's really sometimes you even forget why a certain decision was made. So why you write certain things in a certain way, why a piece of logic is in this class but not in the other. How did you define the abstraction of all those concepts, all those of things. And I think TDD is a way I think it's purposely interrupt so that you do not go into the flow. You keep interrupt yourself and keep yourself honest about why are you doing things. And again, like I mentioned yesterday, writing unit tests is also a great way for us to notice if the design of this particular module or this particular class is isolated enough. Because if you are mocking or stubbing lots of stuff just to test this one module, it is highly likely you did the abstraction wrong. You put too many things together. You let one piece of logic to handle too many things. And I think it's a sign to for you to rethink your decisions. So with all that being said, let's get started. So as you can see, I myself definitely added some code first. Just wanted to have one example instead of keeping everyone together to look at me Googling why things don't work. And I am really glad I did that because I spent just last hour and a half debugging why this test, why the imports in this test case wouldn't work, and when I run pytest, it just gives me an error saying no module error. And so just a shout out to everybody, just remember to put an init file at the root of your test folder, or else things won't work. Adding this empty file took me 90 minutes. Yeah, see, it's always these small things that you just wouldn't know, which waste most of the time. This actually cues whatever I said in my very first video, that writing code actually takes only about 20% of a software engineer's time, and this is a live example. Okay, so in case anybody is not too familiar with the Python tests, so we're using a test framework called pytest and a mock package called pytest mock. Well, you can see like the mock is just a fixture. You don't have to. A fixture is something that you define and be used in the test. So as you can see here, we are using this system provided mocker a fixture, which we can just use. And here we define this state fixture, which we can later use in our actual test. Also, this style of test is called pure function tests, which is a little bit different from the good old Python unit test style. So I myself prefer pure function tests because it's definitely much cleaner. You don't have to define this class. You don't have to write all those redundant self dot. The setup and tear down, you can simply just do it in the fixture, which is really, really nice. So to me, this is definitely the way to go. Yeah, and I just I definitely prefer this over unit test. But as long as you write tests, I think it doesn't really matter. It's just a preference, a very strong preference in a way. Okay, so what we can do here is, by the way, PyCharm also comes with this really nice feature, which is automatically rerun the tests if once it detects any changes. So as you can see here, this test failed because so here the mock event isn't given. So what I'm testing here? What I'm testing here is that I just want to, okay, never mind. Just go ahead. So what I'm testing here is given so say when we have the game setup state and we let it handle an event, we want to know that first of all, the game setup state actually has name of state name game setup, and when it returns the next state, it really it should be the next state we used for initialize the game setup state. Also, when we use actually, you know what? Let me put it game setup state. Let me just put it here, and we can have the test here. So and also when we actually get the next state, we want to make sure that the game ID is actually passed to player service initialize. And speaking of that, I think now I just decided not to have these 3 lines because even though it will be more we will duplicate some code in this test for setting up the why it just won't go down. It's so annoying. Oh, okay. Where was I? Yeah. So even though we will have some duplicated code, but I think in the test it's okay because for tests we don't have to really stick to the dry principle, which is don't repeat yourself, because each unit test it is its own world. So first of all, the test will never be included in the compiled version. So actually, however we want to run it in the prod environment. So it doesn't really matter if we have a bit chunky tests. And second of all, so people ask, what about like changing this one place and change it all over the place? Don't you worry about when you change the test, it's gonna take you lots of work. So the idea is that we want to really apply the open-close principle. The open-close principle is another vital, very core programming principles, which means it should be really open for extending, but really hard for changing the existing behavior. Why is that? Because let's start from the easy part. Why do we want to prevent people or whoever, even the author, from changing the existing behavior? Because an existing model might be used by different module. My bad, excuse me. The existing module might be used by other modules, other systems. We do not know, or it's very hard for us to know the blast radius once we make some behavior change. So if we actually want to change something of this module, it is better for us to actually extend it or even wrap it around to modify certain behavior rather than just change it. So circling back to the unit tests, these tests are used for verifying the existing module's functionality. So the expectation is that once they are written, they are not frequently updated. And even when we actually need to change them, the work is worth it to just keep us honest, to help us to understand what we have changed and what the effect might be. So it's again, this is very opinionated. If you believe otherwise, there's no rule against it as long as you are testing the behavior. But yeah, this is my recommendation, and I stand by it. Okay, so here I have just removed the initialize game setup state. So we want to delete this part, and so yeah, so I learned this from a colleague of mine. I think it's really nice. So you always have given event equals event game ID equals game ID and state game ID type equals event type in okay, let's see. Yep, event type. Yep. So what event type do we have? We have game start event. Let's go back, change this. So okay, we now have our event. Given this event is that, and the game setup state equals to state, and so what event? What else? Game ID SK. So all these are not optional. So let's follow the pattern and fill them up. Game ID, SK ID. Okay, game ID. We have type. We need recipient and payload. Recipient equals this, and payload is just the empty dictionary. Okay, so now we have that. Now it's no longer mock event but just event. We have set up this, and apparently we do not need this marker, so let's remove this. So given game ID, no, I think we can get away with just the user string. I'll show you why in a moment. So now we have an event and we have a game setup state. So given these, when the game setup state is a game setup state dot handle is executed with this event, we can be sure. Well, we want to assert that the game setup name is the actual game setup. Even though we didn't actually provide it, we want to know the next state is the state we actually passed in. And as I mentioned, player service is initialized by event dot game ID. Okay, and here they should let us know that this is all passed. Nice. It should really automatically do it. I don't know why they didn't. But yeah, so okay, see, so the first, basically the baseline we have established. So what else? Is this one unit test covering the happy path enough? Actually, no, not in this case. Here we also have a validation which we only verified the case that the event type is correct. So if the event type actually isn't correct, we are going to have a hard time. We don't really verify actually this if-else statement, which is a problem because now we have something that we didn't verify, and we can't know for sure if anybody is making changes to it. So let's write another test case, which is dev test game setup state invalid event. Perfect. Again, we have the type, event type. Actually, event type, we can add a new one. So other than event type, we want game start event. What else? What else? Game started. Let's have a mission start event. Okay. Okay. Now we have this. Then let's give it here. Now it is sorry, my bad. Event type dot mission start event, right? So it's formatted. So in this case, when game setup is actually called, it's gonna throw an error. So we can't do this anymore. We'll have to do something like with the pytest raises a value error. Well, if it raises something, we know for a fact it's that it's not gonna return anything, so we don't really need to assert on the return value. The game setup state name is still set up. Well, some people argue that if we are, since we have established the happy path, we don't really need this here. Some people argue, okay, well, you have one more verification, why bother? So actually, I don't know. I agree with either or neither or both. So in this case, actually, I want to remove it just to keep things focused. So here, what did we do? We give an event which is an invalid event, or actually, let's rename. Let's just okay, actually even do this, right? So it's invalid event, it raises value error, and we want to make sure that because it is already, it errors out the very first line. We want to be sure that the player service is not initialized and nothing is done. So this is also passed. Let's make sure. Yes, it's passed. To passed. Yeah, I think this is good enough for this particular case. I know this to do, I don't like it, but anyways, let's deal about that later. So now we have the game setup state. Let's actually, do you want to have another state or implement the player service? You know what? Let's have another state because we are focusing on the state handling. So we're focused on state handling. So let's keep the momentum and continue to the next state. So the next state is the team leader assignment state. Okay. Let's come back, create a new file, team leader assignment state. So of course we have class called you know what, I don't want to call it a team leader. I think leader would be enough. There's right, so let's leader assignment state. I even want to call this round voting state. No, you know what? Let's not focus on this. Keep focused. I always do this, which is wrong. Okay, so we do not have any dependencies, so this we don't care yet. And we wanted to implement the abstract methods. Oh god, okay, come down. What is, oh yeah, right, because we need to call the constructor of the superclass. So it's super init, yeah, we'll have to have a new state. State name, leader assignment, let's go there. Boop, boop, boop. Okay, now we have everything. Oh, there's next state. Is it name and next state? Yes, name and next state. So next state we'll have to ask next state as a parameter to pass it in and call it there. Okay, so now we have this. Let's go create a unit test. So do test leader assignment state. Okay, so in this case we need to first have a fixture of state. Okay, now we have this fixture, which later we can simply define this once and use it in all sorts of different test cases all over the place, just to put it in the parameter. So first we wanted to have a dev test leader assignment state. So now, of course, we have a state, and so given leader assignment state equals the state. Okay, so now we have this. We want to know when then we'll have we'll have an event. Let's import this. So the event game ID equals game ID, skid equals skid, event type, blah blah blah. Okay, this event type I don't know what kind of so okay, let's go back to the design. So take a look. So this state accepts multiple events. So when game start, okay, whenever enters this state, we want this state to create a mission, to create a round. Okay, I'm thinking. So, okay, sorry. Let's think about what this state does. So this state does a couple of things. First, when the game setup state, when it transitioned from the game setup state, it would execute the create mission enter action, the create round enter action, and then it should notify everybody those actions, and then transitions to a pending state, which is also the state, and waiting for what? It waits for round voted event. Yeah, so it waits for the players to cast a vote to, oh no, actually no, there's one step before that. So once the round started, it actually notifies the team leader, the current team leader, to nominate a team. So it actually broadcasts that, okay, mission started, round started. Then it should also broadcast, okay, the player, this player is the team leader, and we are pending for that player to propose a number of nominees to form this team. Then what it waits for is actually the event that the proposal is submitted. And what else? So if it goes to the left, so once this is team selection, okay, this is another state. I think we can move to that state. So team assignment is actually another. Yeah, so it transitions to that. But what can enter to this state? So team selection voting rejected should go to this state. Quest completed should go into this state, and the game started. So we are expecting these 3 events. Okay, I should write this down. Okay, game started, team rejected, and the quest completed. Okay, first of all, let's create these 3 events. We go to event type. I wonder if we want to form a pattern that we always use past tense for these events. So as you can see, game started, team rejected, quest completed. Yeah, I think this is a good pattern. I don't like the game start. So here all we have to do is refactor, rename, game started. And here we add the game started, and also here we do a refactor of mission started, and here we enter, and here we change it to this value. So that's, as you can see, how simple this is. We only change this one place using the IDE provided feature to just basically rename things all over the place. See? Yeah, see? So very nice. Okay. So for we wanted to, so mission started, we don't care about now. That is an example we added. So the 2 events were team rejected and quest completed. Team rejected event. Now then I wonder if we want, it's already event type. Do we really want the word event? It sounds redundant. This sounds duplicated and redundant. No, I want to move it. Okay. Equals team rejected. Quest completed equals quest completed. Here I want to remove the event. Here we do another refactor and remove the word event, same as this one. We want to rename that. Perfect. Now, we have these. Then let's come back to our state to actually define the first piece of logic here. You know what? Even before that, let's come here. We do not need this event at the moment. We want to make sure that this we want to know when this well, we don't really, okay, so this is also redundant. We don't really need this, but we do want to know that the name of this state equals to, so name is a property. It's not a function, so there's no brackets. We want to know the name is event. No, this is state name dot leader assignment, and we want to import this. Okay, now test pass again. Very good. So let's. So this is TDD. We write something, we test something immediately. Whatever we just wrote, we want to test it. Okay, now, of course, adding this, should I? Oh, maybe this is why. Yeah, right, I remember. Let's see. Okay, so now we want to verify if the incoming event type is one of the three types, which is game started, quest rejected, and what was it? Team rejected and quest completed. Okay, so what we can do is if event.type not in event type dot event type dot game. It really should give me that. Game started. Event type dot quest rejected, team rejected, and event type dot quest completed. So if it's not in one of these, we want to return a value and explaining that and explaining that these are the 3 kind of events we expect, but we got this. Okay. So another thing we could do is potentially to move this oh my god, is it frozen? Okay, what we can do is to do something like this. Expected event types equals this, and then what we can do here is that we're saying self.x Okay, so we can do something like this to show that, okay, we are expecting these events. Team rejected, no, we're missing one. We are missing game started. Okay, so this is much clearer, and if not, then return self.nextState. Okay, then let's go back to the tests. The event we wanted to be one of the 3. We wanted to be one of the 3. So, okay, here is another cool feature of pytest, which is called parameterize. It looks like this. So pytest test.mark.c parameterize. So the state can actually be so we provide. So basically, it's a way to configure pytest to run a particular test case multiple times. So what we can do here is to make sure oh no, this is not state, this is event type. The event type we want to copy from here and to paste it here. So okay, you'll see how it works later. So what we're saying is that so now the event type, we can add it to the parameter, and we're saying that, okay, just the event type is event type. No, there's no event type. There's type, and there's recipient equals and payload is empty. So we have these, and once we pass this event to the handle method, we are going to get the next state. And when, hey, this is not running, it's not nice, run it. Ugh, very bad. Okay, as you can see, the same test case ran 3 times using the given parameter. So this is a really nice feature. It allows you to write one test and verify multiple combinations or multiple cases, which is something you might want. So, well, of course, there's workaround that, okay, we simply define a parameter called event types equals to this list, then we loop through this list and do the assertion 3 times. Yes, we could do that, but this is much easier. You can see that in the test report, and you just keep your test clean and readable. Some people don't like this. I don't really understand why, but this is a nice trick, and it really helps you to have a clean, understandable unit test. Okay, what else? So once we get in, what do we want to do? We want to notify the no, actually, yes. Okay. First of all, when the incoming event is game started and the quest completed, we always want to create a mission, right? Actually, let me move this. Okay, so the first two, we always want to create a mission. But for team rejected, we don't want to create the mission because we don't know if this is the last round, but we need to check. But after a mission is created, we always want to create a round, so which is what we should do in case of team rejected. So how are we going to create a mission? Of course, we'll dedicate that to the mission service and dedicate start round to a round service. And I think notifying the as we established here in the game setup state, assign each player a role, let them know the known player of theirs, and notify them about this is the work of that particular service. So either it's a player service or mission service or round service. So here we only the state machine only cares about the state, leaves the actual implementation to the service to push down the complexity. So here is exactly what we are going to do. So we are going to use dependency injection to have a mission. We have a mission service, and we'll have a round service. So once we have that, of course, we want to have it here. Dot mission service equals to mission service, and round service equals to round service. So once we, of course, we'll have to create the skeleton of these. Again, let's just do it very quickly. Mission service, class mission service. You know what? Let's skip it. Then we have another called round service. Of course, we have class round service, and we just leave it be. So let's go back, come back here, import the empty mission service. We don't really care. So at this moment, so think from the perspective of the leader assignment state. From the perspective of this particular class, it doesn't really care about the detailed implementation of which next state is. It doesn't care. Just this is what I'm going to give out. So I'm this state. I care about what event do I get, how am I going to behave to that event, to those events, and what lever should I pull? That's it. So, and this is what, and what this next state actually is, how mission service is going to notify everybody the mission has started, how the round service verifies if this is the last round and we should just mark this mission failed. These are all separated concerns. That's why we simply create the skeleton of this mission service and the round service and leave them be, because again, we don't care for now. Okay, so we have that. So let's implement some very simple logic saying that if event type is in if game started or event type dot quest completed. In this case, we want the mission service to start mission. So once it does that, we don't really, once we have done that, team rejected, we'll have to create this round anyways. So let's just start this round and we are going to return the next state. Of course, we are going to go there and define this very simple method, mission service. Okay, let's delete this. Def mission ID, game ID, which is a string. We don't want to do any implementation, and so far the return value is none. And the round service is the same thing. Clear this. Start round. Game ID string return null, and we don't want to do any implementation. Let's come back. We have this, and okay, that's it. This is very simple and straightforward. So what did we do here? Okay, it only cares about two things. So if it's the event we know needs to start new mission. It's going to let the mission service to do the heavy lifting. And with this extra step down, we always want to just start a new round. So the test, what should the test be? So we have established the baseline. Then, of course, just like the last time, we want to create a negative test. So, which is what if the oh no, actually, you know what? Let's deal with the happy path first. Now this particular test needs to be broken down. So so this really should be create with start mission, and we want to have another fixture mission service marker. Yeah, this is exactly what we are gonna do. Pytest of fixture, def round service marker, and do this. So now we have these two fake services, fake dependencies. What we can do is maybe let's be a little fancy and give it. Let's let it know that it looks like mission service, and this looks like round service. Yeah, this is real fancy. Okay, so once we have it here, when we need to so the order doesn't matter because it is matched by name. So what I can do is I can actually add the mission service and a round service here and put it in the middle. And of course use it here. It is mission service first, round service later, and we want to assert next state is the actual state we pass in, and we want to know mission service or the start mission was actually called once by the event.game ID. As you can see, let's run everything. One failed. Why? Because start mission called once and game started. Oh, sorry, my bad. Game started and yeah, quest completed. I'm wrong here because when game started, we always create, then we always start mission, and when quest is completed, we also want to start mission, correct? So in this case, let's rerun it, and everything passed. Nice. So the same exact thing. Okay, we literally copy paste the code. This is a very bad practice in coding, but in testing, it's it's okay-ish. It's less of an issue than when we actually write code. So we want to say that this is without start mission. So now, oh, by the way, so to make things nice, I always like to put things in the right order. So see, there's a state mission service and round service. I just want to move this to the end so that things are not so just keep it nice. And I'll rerun the test to show you that these still passed. So the order of these parameters doesn't really matter. What failed was this. Okay, it was the new test case we copy pasted. Then in here, of course, we do not need this anymore. So the event type, we actually have to define it ourselves, which is event type dot what was it? Round team rejected. I do not like typing. So once we have this, we're gonna get past that. Oh, start mission. Oh, we forgot about here. Round service. This one is very important because no matter what, the round service is always called. So once we have this, let's come here. So in this case, because in this case, the event type is actually team rejected. It's not in one of these. It's not one of these two event types. So we do not want to create mission this time. So we want to make sure that instead of this, we want to make sure that that this method is not called. Let's rerun this. Passed again. So very nice. These we still keep them. No, let's keep this consistent. No, this is both happy path, so we kind of want them. Yet again, let's get these. State. Okay, so here let's follow the pattern. So this is called invalid event. The event type, we can still use the good old mission. What was it? What did we use the last time? Event type, mission started, yes. Here, mission started. So here we change this to invalid event. Here we no longer have this. So we know it's going to raise value error. Of course, using this method, you could also verify the error message, which to me is a little bit of an overkill. So normally I don't do that, but it's up to you. Some people are just, okay. Once we have this, we do not want to verify the name because it's already done in the happy path. We do not have a next date anymore. We want, though, to make sure neither the mission service nor the start, nor the round service, what's called. So it's this. So what we're doing here, we're saying that, okay, given an invalid mesh event, we raise the error first thing when we enter the function. None of the subsequent logic is executed. So let's rerun that. Everything in place. Cool. Okay, I think it's been a while. I'll wrap up today. So what we did today, we implemented yet another state. We talked about again inversion of control and how different modules should care about their own thing, their own logic, and leave everything else alone. And I think we took a closer look at how pytest works. We learned about the fixture. We learned about this very nice thing called a parameterize, and we also learned how to catch an error when we are testing the negative cases. Cool. I think tomorrow we'll continue to implement all these state. I think one state a day is a good rhythm. So we'll be implementing states for the next couple of days. So bear with me. Thank you, everyone. See you next time. Bye.